You will learn how to reflect when when there is a negative involved either outside your function or inside the function. For our first one, we notice that our parent function or the function that we will start with of f of x is 1/2 x plus 1. We have our y-intercept of 0, 1 when x is always 0 on our x-axis or y-axis. We also know that our slope is 1/2, and notice that I put in m equals the change in y over the change in x so that we get the correct slope when we graph it. The most common mistake is to mix them up and get them going the wrong direction. So we want the y value change of our slope up 1 positive and positive 2 for our change in y. Getting our graph all the way across the whole graph. Now we're going to take the outputs of that function. So every output function here on our graph, so this point right here and this point over here, these points down here and these points down here. So we're looking at all those output functions, which is the f of x, and we're just going to take the opposite of them. So let's take a look at this part right here. So our output for this point is 2 units up. So that y value, if it was y equals 2 here, now that would be -2. So we're going to be reflecting that over here to the other side. Same with this point up here. It is 1, 2, 3, 4 units up. So that would be a +4. So when we take the opposite of that over here, the opposite of that output, the y value, it will be 4 units in the negative. So 4 units down. So that reflection across our x-axis. Now I'm going to do the point way over here so that output, the y value output is 2, 4, 6, and it will now be reflected across 6 down. So that's that reflection all the way across. Same thing over here. If we have a -2 for our original function, f of x, we're going to reflect that 2 units to the positive because the opposite of a negative is a positive. And then I'll do my end point over here is 4 units down. So a -4 will now be a +4. And it's that reflection. So I'll graph that, grab my ruler. It's going to take me a little bit of time to get the points all lined up correctly. And we'll extend that all the way to past the edge. So what is happening in our function just by looking at that g of x? We can notice that this negative is that opposite of that function. So all y values are opposites. Notice I did not say negative because the negative ones became positive. So we want to say it, all y values are opposite. So what happened to our graph? So in our graph, that reflection happened across the x-axis. So here we want to say reflects in the x-axis. So again, that horizontal line, what is the horizontal line the x-axis for? It's an equation, y equals 0. So another way to say that is reflects in y equals 0. And that is how we state, just like we stated with the previous ones from our notes earlier of translated up 3 or translated left 2. This is that reflects in the x-axis or reflects in the y equals 0. And we're going to be kind of moving towards this y equals, so it might be better to just start talking about and using that in your writing. Now, if we move to this problem right here, so this one's a little bit more complicated than that one. The blue one, when the negative is outside, it's really easy to think about that. It's the y values are opposite. So if we look at, we're going to have our same parent function of 1/2 x plus 2. So we're going to, on a different graph, we're going to graph that. I want you to graph that piece on there so you can pause and graph that. When we move to h of x, we notice that our opposite is in our x. So that means our input values, x, y, or h of x, our input values will be the opposite. So if we started off with 2, so let's take a look at that when y is 2 right here. Actually, I want to get rid of those. Sorry about that. So when y is, or x is 2, when x is 2, y is 2. But what's going to happen is instead of for our h of function, when x is 2, let me do h of x here. This one's f of x. That means when x is 2, we want the output for when h is negative 2. So when h was negative 2, if I look over here, h is negative 2, that's going to be 0. So now it's going to be that 0 at that point. So when x is 0 over here, it's going to be x is 0, positive 1. So it's a little bit more confusing, but let's look at, if we look at, well, remember when we moved and translated the h and the k? If we look at our function y equals f of x minus h plus k, if we look at this one translates the y values, and we notice that when this was subtraction, it translated the x values. So it went left and right for this one, the h, and the y values went up and down. So we can use that kind of thinking about what's going to happen here. So when the y values up here in the blue, if we look in the blue one, the previous one, the y values were opposite. So we're now inside with the x. So that means all x values are opposite. So if we think about how that will work, we look at, oh, it's not the y values, but it's the x value change over here. So if this x value was over 2, it's now going to be over negative 2. So that reflection happens across the y-axis. So if I grab another point right here, that means it's the x value is 1, 2, or 6. That means it's going to be 6 over to the other side. 2, 4, 6 over to the other side. of the y-axis. And I'll pick this last point up here. That was 10 over. So I know it's going to be 10 over the other side of our y-axis. Now, if we go on to the other part of our graph, it's going to be 2 over, so 2 over. And let's grab our final point down here is 10 to the left, so the opposite would be 10 to the right. So that reflection is going to be all the way over here. And then we'll grab let's do one more. Let's grab this point right here, so that would be 2, 4, 6 to the negative. So now it'll reflect over 2, 4, 6 to the positive. So do you see how that reflection across the y-axis? So I'm going to graph this point. There we go. Takes a little time to get it lined up perfectly. So what that means for our reflection was reflects in the y-axis. And remember, that's a vertical line on the x-axis here. So that means it's x equals 0 is our equation. So let me rewrite that over here. So reflects in x, oh, hold on, let's use the equation for that. X equals 0, which is the y-axis. And that's that vertical line on the y-axis. So that's when x equals 0, so that would be our equation, x equals 0. So to review, and the blue one, the first one, our negative is the y values are being turned opposite, so that means we have a reflection across y equals 0, which is the x-axis. And when we have the negative inside with our x's, that's going to be our x values are opposite and going and reflecting across the x equals 0, which is the y-axis.